Let's now tackle part C, which tells us for t is less than 10, an alternate model for the internal temperature of the potato at time t minutes is the function g that satisfies the differential equation. The derivative of g with respect to t is equal to the negative of g minus 27 to the 2/3 power, where g of t is measured in degrees Celsius and g of 0 is equal to 91. Find an expression for g of t. Based on this model, what is the internal temperature of the potato at time t is equal to 3? So they gave us a differential equation. They want us to find an expression for g of t, so essentially find a solution to this differential equation. And then they want us to use that solution to find the internal temperature at time t equals 3. So the first thing to appreciate, this is in an AP calculus class. And so if they're asking us to solve a differential equation or find a solution to a differential equation, it is unlikely to be a really strange differential equation. It's likely to be a separable differential equation. And then once we find that solution, we just have to evaluate it at time t is equal to 3. So let's rewrite the differential equation, and then let's try to evaluate. Let's see if we can find a solution, and then we'll evaluate. The derivative of g with respect to t is equal to the negative of g minus 27 to the 2/3 power. So if this is going to be a separable differential equation, I want to separate the dg and the dt. So I'm going to treat my differentials like numbers, or variables. So I'm going to multiply both sides times the t differential. And so then I'm going to have the capital G differential, dg, is equal to negative times g minus 27 to the 2/3 power dt. And the whole notion here, I'm trying to get all of the g things on the side with the dg, and then all of the things that involve t on the side with the dt. So we don't see any t's here, so really we just have to get the g's over on this side while leaving the dt there. And then we can integrate both sides. So let's see. If we were to divide both sides by g minus 27 to the 2/3, g minus 27 to the 2/3, g minus 27 to the 2/3, what do we have? Well, we can rewrite the left side as g minus 27 to the negative 2/3, dg is equal to, I'm left with just this negative dt is equal to negative dt. And let's see, now we can, or actually just to simplify, or just to make it a little bit more obvious, I could write that as negative 1 dt. And now we just have to integrate both sides. So we could rewrite this as, let me write an integral sign. I'm going to integrate both sides here. And so what is this going to give me? Well, on the left side here, you could try to do some u substitution, saying u is equal to g minus 27, and then du would be dg. Or you might recognize that, look, the derivative of g minus 27 is just dg. The derivative of g minus 27 is just going to be equal to 1. So you could even say, look, I have the derivative there, so I could really integrate with respect to g minus 27. And so really I would just use the reverse power rule. I would take my g minus 27. I would increment this exponent by 1. So see, negative 2/3 plus 1 is positive 1/3. So positive 1/3 power. And then I would divide by this new exponent. So dividing by 1/3 is the same thing as multiplying by 3. So that's the left-hand side. This is going to be equal to the right-hand side. This is just going to be negative t. And for good measure, I'm going to have a plus c right over here. So how can we solve for c? Well, they give us some information. They say g of 0 is equal to 91. So let's write that down. So when t is 0, g is 91. So we can write, let me write it over here. So 3 times, so when t is 0, g is 91. 91 minus 27 to the 1/3 power is equal to negative t. Well, now we're saying t is 0. So we could write negative 0 there, or we could just not write it. And then plus c. So that's what c is going to be equal to. Let's see, 91 minus 27 is 64. 64 to the 1/3 power is positive 4. And so we have c is equal to 12. c is equal to 12. And let's see, we want to write an expression for g of t. So now let's just manipulate this and solve for g. So let me just take this and go right over here. So if we divide both sides by 3, we are going to get g minus 27 to the 1/3 power is equal to negative t over 3 plus 4. I just divided both sides by 3. Now I can take the cube of both sides, and I would get g minus 27 is equal to negative t over 3 plus 4 to the 3rd power. And now I just have to add 27 to both sides, and I'll make it clear. G as a function of t is equal to negative t over 3 plus 4, all of that to the 3rd power, plus 27. So I did the first part. This is, well, let me not cross it. This right over here is an expression for g of t. It was indeed a separable differential equation. It took a little bit of algebraic manipulation to get us there, but we were able to do it, and we were not only able to solve for the general solution, we were able to find the particular solution using this initial condition right over here, that g of 0 is equal to 91. Now, we'll do the easy part. Based on this model, what is the internal temperature of the potato at time t equals 3? So g of 3 is equal to negative 3 over 3 plus 4. Let me just write it out. Negative 3 over 3 plus 4 to the 3rd power plus 27. Well, this is negative 1. So negative 1 plus 4 is 3. So this is 3 to the 3rd power, which is 27, plus 27 is equal to 54 degrees Celsius. And we are done.